the rules for working with these in 9.3 are extremely long-winded. So what I've done is I've taken this big, giant, nasty-looking rule set and cut it down into stuff that makes sense. Let me show you what I mean. In order to graph polynomial functions with no common factors other than 1, the graph, the real, blah, 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 has all of this. There's a lot going on here. This mirrors the same idea of what we did yesterday, polynomials P over Q. Same idea. The only difference now is that we have degrees to worry about. We're going to have squares, cubes, fourth degrees, things of that nature. So what happens here is that I've cut this down to make it look a lot easier. And I'm going to put this up in tandem with an example that I have on the next sheet and bring it over. And hopefully you will see where this is coming from. So when we're working with these, we're going to follow some rules. And this is for the rules for graphing. These are all of our rules. There's only 3 of them. Yeah, you need to know these. There's going to be 3 rules that we abide by. When we're working with these, and we're going to graph out these rational functions, there's 3 rules we're going to start with. The first of the rules is to always identify the x-intercepts of the functions. And the x-intercepts are at the zeros of the numerator, which means sometimes you're going to have to factor it, sometimes you're going to set it equal to 0, and if it's a constant, that means there's no x-intercepts. There's a couple of things. I've got a bunch of examples today to show you all these different variations. So in the example that I have right there, I've got y equals x squared plus 4x minus 5. That's my numerator. To identify the zeros of that, I would have to factor it. Yeah?
I was going to ask you about
I'll get into it as I bring it through. Okay. If I go to factor x squared plus 4x minus 5, when I set that equal to 0, again, I'm asking what times what is negative 5, but yet you add it together to get positive 4. Good. 5 and negative 1. So it's x plus 5, x minus 1, bless you. Good. So my zeros would be at negative 5 and 1. Okay? I'm going to kind of bring it through at the same time here. You know what? I'll just do this. I'll just write this out first. The vertical asymptotes is step 2. Vertical asymptotes occur, again, always at the zeros of denominators. Because, Hunter, you asked me this again, why is it always the denominator? Because what?
Can't be over 0.
Right. You can't divide by 0. You cannot divide by 0. That's bad. So you have what's called a vertical asymptote. In order to solve for your vertical asymptotes, again, sometimes you might have to factor if it's a square term, a cubic, or one of those. If it's a linear term where it's just x minus 6, we might be able to now just look at that and say, well, what's the 0 for x minus 6? 6. So my vertical asymptote would be at x equals 6 in this example. All right. Those two are usually pretty straightforward. In fact, you set them both. Set the numerator equal to 0. Those are your x-intercepts. Set the denominator equal to 0. Those will be your vertical asymptotes. The third step is usually where most students get a little messy.
Hey, how do you do this?
I set this equal to 0.
Oh, yeah.
Okay. Now, you guys were starting to ask about this whole m and n. These m and n are the degrees of the polynomials. The m is always the degree of your numerator. Oops, I can spell. Is the degree of the numerator? There is 2 e's in degree. It just didn't look right. Says the guy with 1,000 lights outside the door. And the n is the degree of the denominator. Okay. And again, to solve for your degree, you're looking at the highest power. Usually it's going to be extremely straightforward. They're going to put things in descending order when they're talking about these polynomials. They don't normally mess with you on that. I don't think I've seen a problem in the book at all that writes things differently. That's just kind of mean. Okay. So you have three possible cases to look at for the last step. The first case you look at is if the degree of the numerator is smaller than denominator. Is the degree bigger? Or are they equal? Those are the three possible scenarios to look at. In our example here, I have a degree of the numerator, the m value, is 2. Everybody agree with that? It's a second degree polynomial. The degree of the numerator, or excuse me, the denominator is what? So is the numerator larger, smaller, or equal? Larger. So that means that m is greater than n. So is there a horizontal asymptote? No. So what I'm doing here is I'm taking this information, these cases, looking at this example, and getting some information to be able to rough sketch a diagram. Our diagram then would start to look like this. According to the information that we already know that we have x-intercepts at -5 and 1. Put a dot there. -5, 1. I know it's going to cross the x-axis. I also know that I have a vertical asymptote where? 6. So I draw on a vertical asymptote at 6. Oops. Missed it. Do I have a horizontal asymptote? No. For right now, do I have enough information to continue? I do have enough. How am I going to find my other sets of ordered pairs? Use your table function. Okay? But for right now, I'm not really worrying, I'm not concerned about the graph. I'm not worried about the graph because if you guys can show this information, anybody can press buttons on a calculator to get ordered pairs. Do you agree with me on that? The information that I want you to be able to set up is, can you set this information into this? Can you get just this parameter to start with? That's all I want to be able to do today. I want to be able to go through these steps of information to get a rough idea of where it's going to start to look like, and then tomorrow we'll just start using table functions. It's a lot easier. Okay? That's it. For right now, that's all we have. The line, that vertical line was the vertical asymptote. Okay. So for, what I'm doing here is, again, I'm just starting with find my x-intercepts, find a vertical asymptote, find a horizontal asymptote, sketch that. That's all I want to sketch. I'm not putting any curves in here whatsoever. I don't care about that yet. We're going to worry about connecting the dots tomorrow. Bless you.
Bless you.
Oh, pretty. It's all over you.
All over?
That was good. That was good. Let's look at another one. Let's look at this one.
Mubby. Mubby margin.
What did you stop? That was not even me.
Stupid teachers.
You're not going to get any pizza. Again, as we start this one out, I have y equals 3x squared minus 13x plus 10 all over x squared plus 8. When I start the problem, I'm going to find my x-intercepts. My x-intercepts are going to be at the 0 of the numerator. So I set it equal to 0. And again, I need to factor.
You shouldn't.
I shouldn't. What's 3 times 10? What times what is positive 30, but if I add it together, I get negative 13.
Oh, you can do
Yeah.
-3, -10?
So we have 3x squared minus 3x plus 10x, oops, excuse me, minus 10x plus 10, and I have to factor it by grouping. Factor GCF in the first group, you have 3x, left with x minus 1. Factor out a negative 10, you're left with an x minus 1, which gives you 3x minus 10 and an x minus 1 for your 0. So if you have 3x minus 10 and x minus 1 as your terms, your zeros would be positive 1 and 10 over 3, 3 and 30. So it's at 1 and 10 over 3. Okay? Those are my x-intercepts. Go to the second step. The second step is to identify your vertical asymptotes. Your vertical asymptotes are going to occur at the real solution, the real zeros of your denominator. Careful. I have x squared plus 8. Is that going to give me any real solution? So do I have any vertical asymptotes? No. So here I have no vertical asymptote. Again, everybody understand why there's no vertical asymptote? If I take x squared plus 8 and I set it equal to 0, I can't have x squared equal negative 8. I'm looking for a real solution here. All right, so this is why I have no vertical asymptote. The last step is to identify the horizontal asymptote. What's the degree of the numerator? What's the degree of the denominator? Does 2 equal 2?
Yeah.
Okay.
Oh,
So-
that's how you do that.
In this case, since the degrees are the same, what happens now is that you look at the coefficients of the highest power. Just like you did yesterday with the ax plus b and the cx over plus d, my coefficients are 3
Over 1.
and 1. So my my horizontal asymptote is at, oops, can't write. Again, the reason that it's at 3, since our degrees were identical, they both had a power of 2, m was 2, n is 2, those are the same, therefore the fraction a over b, which is the coefficients of those highest powers, is your horizontal asymptote. From this information now, I know enough to generate a rough sketch. Again. I have intercepts at 1 and 3 1/3. There's no vertical asymptote, but there's a horizontal asymptote at 3. For right now, that's all we need to do. The rest of the graph we'll be able to find by using table functions. TF. Okay? Okay? We okay?
Yeah, it doesn't seem that. It's just gonna take forever.
Is it Christmas yet?
No, it's gonna get forever.
There's going to be a bunch of weird ones. You're going to see a bunch of weird stuff going on. Let's take a second then and try this next one. Oops. Bless you.
Is this quiz going to be calculated?
I'm going to have it set up in this same exact manner. We're going to have to identify all these values. You don't need to use a calculator to do that. And then I might have a part where you'll use a table to fill in it.
You don't take graphing calculator?
No.
Those calculators
That breaks my
probably
back
cost me
because
like
me and this guy.
They were telling me things.
So again, when I start this problem, I have y equals 2x squared minus 9x minus 5 all over x squared minus 16. Your first goal is to identify your x-intercepts. And where are your x-intercepts located?
I'm not ready.
Don't say on the x-axis.
Let's multiply 2 and 5, right?
Is it 2 and 5 or 2 and negative 5?
2 negative 5 might be.
So you're right, you got to factor your numerator.
Ooh, I'm guessing it's 10 and negative 1.
Times x minus 5.
Yeah. 5? Wait,
No, x minus 5. Includes plus 5.
Oh, thank you.
Murphy, I'm so confused.
He factored it already for us.
Why isn't it?
He already factored it.
Yeah, but wouldn't it be 10 and negative 1?
This becomes 2x squared minus
Don't you have to
10x
multiply
plus
2?
1x minus 5. We did. And he, Mustafa already just went ahead and he factored it out quicker. He finished it already.
Well, skipping steps.
It's all right. So your zeros then are located at?
Negative 1/2 and 5.
Good. So I know my zeros are located at negative 1/2 and 5. Will I have zeros in my denominator for this case?
Probably not.
My vertical asymptotes?
4. It's not.
Plus or minus.
Oh, well, I don't play those games.
Don't forget, when you have the square terms, gotta make sure you do plus minus here.
So you have 2 vertical?
Yeah.
It's
You have
almost
2
like an
vertical
H. Ooh, I was on
Okay. And then lastly, our what do you call it? Horizontal asymptote. Forgot what it's called. Thank you. The horizontal asymptote.
That's, oh, yeah.
What do we know about our degrees?
Even. So it's 2 over 1.
See that?
Two.
That's a little power show.
It really was a 4.
What?
Lightning.
I thought it
actually.
came from over here. The light.
Oh, it's there
I
for
missed
the
someone's phone.
So the horizontal asymptote, since the degrees are the same, they're both second degree polynomials, I look at the coefficients. What's the coefficient in the numerator then?
2.
And the denominator?
1.
So it's at y equals 2. The rough sketch of the graph then.
Mr. Murphy, did you see the Lions game?
Nope.
It was
Are you a Bears fan?
quite good.
I just didn't watch that. I had other stuff to do. From here, start plotting stuff. I know that my zeros were at negative 1/2. Oops. And 5. I had vertical asymptotes at plus and minus 4.
Wait, so that is that, like, point on 5, is that allowed?
Yeah. Because let me show you what's happening here.
Looks so good.
We have those 2 vertical asymptotes, and then there's a horizontal asymptote at 2.
What is those guys? Those blue guys.
If I'm looking at this graph, did that graph just get, whoa, sorry.
What are those blue dots? Mr. Murphy?
Those are the zeros.
Oh.
Those are the intercepts.
Negative
Now,
1/2 and 5.
does everybody see how this graph has been sectioned into 6 parts?
Yeah.
Which means that there could be, the graph could be occurring in any one of these 6 positions. And now you've already graphed it in your calculator, and it's pretty funky, isn't it? I believe, what is it? It's going zigzag in the middle?
I saw
I think
that
it's the
too.
sun. It might be the sun.
I think it's a.
Yeah, it's a zigzag in the middle. And these are these special cases that weird things are happening.
Oh, man.
The graph will look like that. Now, obviously it's crossing the asymptote in between, but that's happens sometimes when you have these setups like this. Okay? Don't worry about the graphing of this tomorrow, right now, because this stuff you're going to be able to find by using the table. You'll be able to plot points via the table. What I want you guys to be able to do tonight is work with these things to set it up. Does that make sense? And it all stems from being able to work off of the x-intercept, zeros of numerator, vertical asymptotes, zeros of denominators, and then going through the three cases. Yes, sir. Is he coming up here?
No, he's just gonna
Oh, go ahead if you want to go grab it. Yes, sir.
drop. Do we even need the graph picture?
You know what? I want you to put them on the graph paper to start with tonight, and that way we'll use these as examples tomorrow to fill it in the tables.
Oh,
Does that make sense?
yes.
Yeah.
You put that whole thing in your calculator?
You can. Yeah. If you go to the y equals thing and do your alphas, do alpha y equals and create the fraction, you can type that whole thing in there. You're happy about it. See, you're up there now. I hustle.
Probably, yeah, every single picture. Pretty good.
The newspaper.
But you
I
have
read the
to-
newspaper when I'm eating breakfast.
But you have to keep going with kilograms. I remember that from the bus.
That was awesome.
I remember what she called.
Not so bad? Let me give you guys 6 of these to try for tonight. Yeah, I'll get you a piece of graph paper. No, it's 6 of these.
Only 6?
Yeah.
Can you get us the page numbers?
Yep. What I want you guys to start with, it's on page 551. It's these 3, or 6. And I want you to just do the rough sketch. I want x-intercepts. I want vertical asymptotes, horizontal asymptotes, and that's all I need you guys to be able to plot. I want you to, just like we did in class, identifying all them, listing them out, do the same thing with those 6. I'll give you a piece of graph paper, and then tomorrow we'll take it a step further and start connecting dots.
It's in your rack. In the back, a lot of the sharp.
Oh, I got a whole bunch of it.
Oh, I have. Mike could cover it.
I mean, seriously, there's a ton of graph paper lying around.
And Jason's mom tells me that.
Who?
Where'd all the graph paper go? Here, you get one. Does anybody need graph paper, or do you have enough for still?